Harrison Owen rightly said that when the spirit of the people is strong, focused and vibrant, wonderful things happen. Hi, I'm Arjun Bhagat, and today at Toppers Exam Special, we'll revise the chapters D and F block elements and coordination compounds. So let's kickstart the episode by figuring out the weightage and trends followed in the exam. Here comes our first segment, Trend Spotting.
The unit D and F block elements carries a total weightage of 5 marks, and the unit coordination compounds accounts for 3 marks out of the total 70 marks chemistry paper. So both these topics together make up for about 11% of total marks. So that was about the weightage. Now coming to the types of questions. From this topic, one can expect short answer type questions worth 2 to 3 marks.
While some people follow a set pattern to take the examination, there are others who use their mental ability and skills and win that race. We at Topper TV also aim to provide such critical and beneficial skills. So let's begin the process by recapping whatever we learned through these chapters.
In this chapter, we have already studied about the general configuration and characteristics of D and F block elements, some important compounds of D block elements, coordination compounds, and then nomenclature, bonding and isomerism in these compounds.
I know after spotting the trends of the past years, you would want to know what ability type the examiner is testing you on. Well, we'll fulfill this wish of yours in our next segment, Knowledge Dip.
Well, you would generally find the platter of questions that put your conceptual and knowledge skills to test.
I'm sure that you're all set to hit the question and answer round, but before that, it's vital that we solve a model question. This question will prepare you better for the final game.
Here you are asked to state the reasons why 1. The transition metals generally form colored compounds. 2. With 3D4 configuration, Cr2+ acts as a reducing agent, but Mn3+ acts as an oxidizing agent. The atomic number of chromium and manganese is equal to 24 and 25 respectively. 3. The actinoids exhibit a larger number of oxidation states than the corresponding lanthanoids. This question is a 3 marks conceptual problem that was asked in CBSE 2008 examination. So for the answer to part 1, you have to write that the transition metals have unpaired electrons in the n-1 d level, which on absorption of light of a particular wavelength undergo d-d transitions and emit light in the visible spectrum range. Therefore, they appear colored. In part 2, we have to tell that why, with 3D4 configuration, Cr2+ acts as a reducing agent, but Mn3+ acts as an oxidizing agent. As we know, Cr2+ has 3D4 configuration. It loses 1 electron to have a stable 3D3 configuration. As a result, it acts as a reducing agent. In case of Mn3+, also the configuration is 3D4. But it gains 1 electron to get a stable 3D5 configuration. So it acts as an oxidizing agent. And for the last part, you should write that the 5F, 6D, and 7S energy levels in actinoids are of comparable energies. Therefore, all these 3 subshells can participate. However, the difference in energy of 4F, 5D, and 6S energy levels in lanthanoids is greater. It is for this reason that actinoids exhibit a larger number of oxidation states as compared to lanthanoids. Remember the configurations of D block elements correctly.
After attempting this model question, you must be confident enough to do a few practice questions. So So here you go. Take a look at the first one.
So you have to tell that what is lanthanoid contraction and what are its consequences. This is a knowledge-based question and was asked in 2007 for 3 marks. Topper rates it as an average difficulty problem. In the answer, you should write that the steady decrease in the atomic and ionic sizes of lanthanoids with increase in atomic number is called lanthanoid contraction. It is caused due to poor shielding of 4f electrons. And the consequences of lanthanoid contraction are: 1. The basic strength of the hydroxides of lanthanoids decreases with increasing atomic number. 2. The elements of second and the third transition series exhibit similar radii and have similar physical and chemical properties due to lanthanoid contraction. Remember that actinoids also show actinoid contraction similar to that observed in lanthanoids, and the contraction observed is even more in the case of actinoids.
Was this question difficult? I'm sure it wasn't, because at Topper, we make even difficult things easier for you. To ease your preparation further, let's attempt another question.
Here you were supposed to write the steps involved in the preparation of 1. K2CR2O7 from Na2CrO4 and KMnO4 from K2MnO4. This question is worth 2 marks and tests your knowledge ability. It is rated as average on Topper's judgment meter. Read this question carefully. It requires only specific steps. So don't waste time in writing all the reactions involved. Let's talk about the preparation of K2CR2O7 from Na2CrO4 first. The yellow solution of sodium chromate is acidified with sulfuric acid to form sodium dichromate. This sodium dichromate is then treated with potassium chloride to get potassium dichromate. Coming to the preparation of KMnO4 from K2MnO4. Potassium manganate is oxidized to potassium permanganate by oxidation with chlorine. You should also remember the balanced equations for these reactions.
By now, you must have started enjoying the practice questions. But to clear any existing doubts and confusion, let us try some more practice questions. This should help you in better understanding the topic. Here comes the third one.
The question asks you to account for the different magnetic behavior of hexacyanoferrate 3 and hexafluoroferrate 3. This is an average conceptual problem worth 3 marks. In the answer, you should write that the ligand cyanide ion in hexacyanoferrate 3 is a strong field ligand, and therefore electrons pair up in the D subshell, leaving only one unpaired electron. On the other hand, the ligand fluoride ion in hexafluoroferrate 3 is a weak field ligand, and therefore electrons in the D subshell do not get paired up, and thus it has 5 unpaired electrons. More the number of unpaired electrons, greater is the magnetic moment. So, hexafluoroferrate 3 has a greater magnetic moment than hexacyanoferrate 3.
So how are you finding this session? Well, I'm enjoying solving these problems, but I do need a small break for my tea. Before that, let me tell you about our website, and that's www.topperlearning.com. Visit it and find a large bank of questions along with their answers. Well, after the break, there's loads of practice questions coming up. Plus, there's also a unique HOTS problem and special tips just for you. In the meanwhile, don't sit idle. Solve this breaking question.
So which element of the first transition series exhibits the largest number of oxidation states? Think of the answer while I return. We had left you with a question before the break. The question is, which element of the first transition series exhibits largest number of oxidation states? So the answer is, among the elements of the first transition series, manganese Z is equal to 25 exhibits maximum number of oxidation states. That is, from +2 to +7.
Welcome back to the exam special on D and F block elements and coordination compounds. I'm Arjun. Till now we've done a model question on the properties of D and F block elements and practice problems related to lacinoid contraction, preparation of D block compounds and behavior of coordination compounds. But there's a lot more to do since time is precious, so let's quickly get on to our next practice question.
This question asks you to explain the effect of pH on chromate and dichromate ions. This problem tests your knowledge ability, has been picked up from the sample papers. It is an average as per Topper's difficulty meter and is worth 3 marks. You must know that chromate and dichromate ions are interconvertible by changing the pH of the solution, and they exist in equilibrium at pH 4. When an alkali is added, that is the pH of the solution is increased, the OH- ions will combine with the H+ ions and thus the concentration of H+ ions will decrease. According to Le Chatelier's principle, the reaction will shift towards forward direction producing yellow chromate solution. On the other hand, when an acid is added, that is, pH of the solution is decreased, the concentration of H+ ions will increase. Therefore, according to Le Chatelier's principle, the reaction will shift towards backward direction, providing orange-colored dichromate solution. Remember that chromate ions are present in alkaline solution, while dichromate ions are present in acidic solution.
If you're looking for a big opportunity, find a big problem, said Anon. And I say that though our next problem is not that big, but take it as a big opportunity.
1. In this question, you need to give the IUPAC name of CrCl2H2O4Cl. 2. Name the isomerism exhibited by the two coordination compounds CONH35BrSO4 and CONH35SO4Br, and give one chemical test to distinguish between these two compounds. This problem is for 3 marks, it is knowledgeability question, and Topper's difficulty meter rates it as average. So, for the first part, you'll tell that the IUPAC name of CrCl2H2O4Cl is tetraaqua dichloride chromium 3 chloride. For the second part, write that the coordination compounds CONH35BrSO4 and CONH35SO4Br show ionization isomerism because there is an interchange of groups between the coordination sphere of the metal ion and the ions outside coordination sphere. Now, for the test to distinguish these coordination compounds, add an aqueous solution of barium chloride to both of them. CONH35BrSO4 will give a white precipitate due to the formation of barium sulfate, while CONH35SO4Br will not give any precipitate. In the naming of coordination compounds, remember that when the complex is anionic, the name of the central metal atom ends in ate. While for cationic and neutral complexes, the name of the metal is written without any characteristic ending.
Now that the mood is set, let's take another question which again tests your knowledge ability. Take a look at the question now.
Here you are required to name the heaviest transition element in terms of density. Then you have to tell that which ions would form white complexes: Cu2+, Zn2+, Ti3+, Ti4+, or Cd2+. The question carries 2 marks and is a knowledge ability question. As per the difficulty meter, it is an average one. Here comes the answer. Osmium is the heaviest transition element. For the second part, write that the ions having either D0 or D10 configuration will form white compounds. Since Zn2+ has the configuration 3D10, Ti4+ has 3D0 and Cd2+ has 4D10 configuration, they will form white complexes. Remember that the color of compounds of transition metals is because of the incomplete N-1d subshell.
Well, that was the last practice question. I'm sure now you can answer all the questions from this topic. It's now time for high order thinking skills. Yes, I mean the HOTS question. It has been introduced by the CBSE to test high order thinking skills of students and probe them to think beyond books. So take a look at that.
You are supposed to give reasons for why transition metals have high enthalpies of atomization. Among the lanthanoids, cerium-3 is easily oxidized to cerium-4. Transition metals form alloys. This problem is a conceptual one and carries 3 marks. It involves the application of properties of transition metals and lanthanoids. For the first part, write that the transition elements form strong interatomic bonds due to their small size and due to the presence of large number of unpaired electrons in D subshell. Therefore, they have very high enthalpies of atomization. In the second part, we'll write that among lanthanoids, cerium-3 is easily oxidized to cerium-4 because Ce4+ has stable electronic configuration like xenon. That is why Ce3+ is easily oxidized to Ce4+. Now for the third part, write that the transition metals are quite similar in size and therefore atoms of one metal can substitute the atoms of other metal in its crystal lattice. Thus, on cooling a mixture solution of 2 or more transition metals, an alloy is formed.
So you finally mastered it and you're now a champ. But don't think that the battle is over till you don't take the final exams. Don't stop practicing. You can find more such questions and study material on our website, and that's www.topperlearning.com. Okay, now there are small little things which, if you keep in mind, can make learning and examination a piece of cake. Yes, you guessed it. It's time for the exam tips without which no preparation is complete. So here they come.
Remember, that if a complex is formed by the use of outer d orbitals for hybridization, it is an outer orbital complex, while if a complex is formed by the use of inner d orbitals for hybridization, it is an inner orbital complex. Practice questions based on nomenclature of coordination compounds, as a question is always asked from this topic. Remember that a strong field ligand forms low spin complexes, while weak field ligands form high spin complexes. Remember the variations in properties of D and F block elements and emphasize on reasoning. Also, emphasize on the various uses and oxidizing properties of the compounds of D block.
I hope you enjoyed today's class. It is said that good teaching is 1/4 the preparation for exams, and I hope at Topper TV we have excelled and proved that statement right. Now it's your turn to work hard, keep revising your lessons and do well in your examination. Do join us on our next exam special episode. Till then, take care and goodbye.